Section 3.3 is multiplication and division of whole numbers. So to start with, a basic definition. For finite sets A and B, the number of items in A equals A and the number of items in B equals B. Then if you take n times A, this equals A plus A plus A plus A. How many times? N times. If you have 0 times A, we're going to define that to be the number 0. And if you have two numbers, that is n of A equals little a, n of B equals little b, and you multiply A times B, that is actually the value of the, have you ever seen this before? Cartesian product? The Cartesian product. And we saw this equation before when we did that. It's the number of ordered pairs if you grouped things one at a time. This is the definition for multiplication. And we're going to do the same thing we did in the last section when we talked about subtraction. We're going to have 3 models for multiplication. Okay? So the first model for multiplication is the repeated addition model. Giselle takes 3 tests every Friday. After 4 Fridays, how many tests has she taken? Well, right, this is 3 times 4, obviously. But because it's 3 times 4, this is the idea of repeatedly adding the 3 together 4 times. She's taken 12 tests. Repeated addition. Array is one of my favorites. Minhu is baking cookies. He's able to place the dough 3 cookies wide and 6 cookies long in his pan. How many cookies will his pan hold? So this one has a very natural picture associated with it. In fact, you're probably all in your mind seeing the picture even as I described it, aren't you? Okay, so it's supposed to be 3 wide, 6 long. We need circular cookies. I don't think that it's going to work if I do others. So ignore the fact that they're not perfectly circular and they're not in perfect rows. Probably actually looks a lot like his cookie sheet, to be honest, right? Okay, it's an array. It's 6 wide, it's 3 long. How many cookies will his pan hold? How many cookies was it? 18. 18 cookies. 6 times the 3. Yeah. Okay, area model is almost exactly like an array model, but an array model is actually whole objects. Again, we're not talking about half of a cookie, right? It would be weird to talk about it like that. For an array model, we don't use partial pieces of things. An area model is like it's the equivalent to the measurement version of this. Alexis is planting a garden. She has a space that's 5 feet wide and 7 feet long. How much area does she have in which to plant? So on this one, we actually have a rectangle that we're going to draw. And if you want, you can think about sort of subdividing the rectangle. It said 5 wide, 7 long. So 1, 2, 3, 4, 5. That's definitely not drawn to scale. Sorry about that. 1, 2, 3, 4, 5, 6. Definitely not drawn to scale. Sorry about that. You guys can have better pictures than mine. So if you've got 7 long, this is 5 wide, and it's this 7 long, how much area do you have in which to plant? 35, and it's actually feet squared or square feet. We say square feet. It looks like feet squared when we write it down. But 35 feet squared. If you were to actually count all the boxes, it would count up to 35. Okay? Do you have to draw the grid inside? No, you don't have to, but that's the image that we're getting when we draw this. So a area model is the same idea as an array model, isn't it? It's just that it's measuring things that have measurement instead of whole objects. So some people want to think like, okay, anytime I talk about a garden, I'm talking about a measurement model. And the answer to that's actually not true either. You can talk about a garden and talk about the length and width of the garden, and then it'd be a measurement model. If you talked about planting rows of corn, those are objects, right? Whole number objects. That would actually be an array model. All right, so we'll stop there for today.